There's a nice old mathematics building on the Columbia University campus in New York City. You'll find Professor Richard Hamilton here about half the year teaching. If it's summer, he'll more likely be at his home on the north shore of Oahu in Hawaii.
I suffer from allergies and chronic sinusitis. It really helps if the sun's shining and the air's dry. Then I'll get filled with energy, and then I'm likely to think of good ideas. But I'm just as likely to think of bad ideas because I try thousands of things.
Richard's work on the Ricci Flow started in the mid-1970s. By 1982, he had published his first result with the Ricci Flow. The equation makes shapes more regular by giving them constant curvature.
dg dt equals minus twice Ricci. These d symbols here represent the rate of change. G represents the geometry, and Ricci represents the Ricci curvature. You have some odd shape that you start with, and then you run this flow, and then it turns into something that's very uniform with an equal curvature.
Here's an animated example of what happens to a shape under the Ricci Flow.
This big curvature at this end is starting to move into the cylindrical part where the curvature is small, and then the curvature gets big all over the sphere, and then the whole sphere starts shrinking down, and as it shrinks, it gets rounder and rounder. And in the limit, you get a completely round sphere.
Why do you want to run the Ricci Flow on something?
The idea is to get a really good, ideally a perfect geometry on it, so you know exactly what the topology is. Because when you have a perfect geometry, then it's a standard shape that we understand.
Our spaces, when we talk about topology, don't have size or shape. They can be pulled and pushed. They cannot be torn.
Mathematician John Morgan is a former colleague of Richard Hamilton's at Columbia.
We were going after people in those days who had established their mathematical credentials, and Richard was certainly a great catch for us.
Morgan says Hamilton was on his own developing Ricci Flow.
This is a field he built more or less by himself. It didn't attract that much interest until its power and worth was proved out, and then it attracted a lot of interest.
Former grad students Steve and Lonnie count Richard as a teacher, mentor, and friend.
He taught us what it means to be a researcher, what it is to choose good problems, what good taste is in research.
I think it's more than just the science itself, it's how you look at life.
Richard's reputation grew when another mathematician, the Russian Grigory Perelman, used Ricci Flow to solve a 100-year-old challenge in mathematics.
And so I sat down with him for an hour or so and explained the general ideas in a program that I had developed for using the Ricci Flow to prove the Poincare conjecture. I'd developed a lot of the pieces, and he filled in some things that I didn't know how to do with very clever new ideas and completed the program.
Perelman, though, turned down the $1 million prize offered by the Clay Institute for proving the conjecture, saying Hamilton, too, deserved credit.
He was very generous in his remarks about me and said that the work that I did was as important as his. I'm completely delighted with that analysis.
For years before getting here, Richard Hamilton had dreams and ideas about what Hawaii would be like. And as nice as it was made out to be, living here has still been beyond his expectations.
And often I'll be out there and a turtle will swim right up to me, you know, like within a few inches, just kind of saying hi. That's a lot of fun.
Richard and his housemates, Red and Brenda, will swim with dolphins when they spot them coming close to shore. They get close to sharks, too.
Red got a nice picture of this shark coming up to check me out, and I can put my hand up like that, and he immediately turned sideways.
Play is fuel for the work Richard does.
If I'm thinking real abstract or wondering what to try, then often it's best to be out and active. Other times I have to do a whole lot of calculating. And for that, it's best to just sit where there's no distractions and where you're completely comfortable.
Tidal waves along the shores of Greece. Newton thought the ebb and flow is caused by Earth's gravitational force. In Einstein's theory of general relativity,
the same effect is described as the effect of the space-time curvature. This is within this conceptual framework that my work lies.
Demetrius Christodoulou's work from 1984 to 1991 was actually on Minkowski's flat space-time. Imagine a quiet lake as flat space-time and throwing in a stone causing some initial disturbance or curvature.
We solved this problem for all time and showed that it actually propagates into waves called gravitational waves.
In 1991, he discovered what's known as the Christodoulou memory effect.
The waves pass away, but this leaves a memory.
The lake of space-time becomes flat again.
But the initial space-time and the flat space-time, although they are both trivial, being flat, they are not related in a trivial manner. And this non-trivial relation is manifested in the memory effect.
In 1965, Penrose found space-time contains trapped surfaces.
The trapped surface must be contained in a black hole, which is inaccessible to observation from infinity. It could not be proved that such surfaces actually form in evolution, but I did find such a method.
In 2004, the short pulse method came to Demetrios when he was half asleep.
A picture formed in the back of my mind, then became more and more intense.
It was a plateau with a large slope into a plane.
I am able to capitalize on the abruptness of this change, to carry out the analysis all the way through, to where interesting things will eventually happen. In this case, the formation of the black holes.
After 4 years, Christodoulou published a 600-page paper on the formation of black holes in general relativity.
To make sure that there is an absolutely rigorous proof in all possible respects. I had even nightmares for a year afterward.
Wife Nicoletta, who paints triptychs, was sure.
At that night, I think God has put his hand on me.
She saw a halo on Demetrios.
This light, I knew that was something very, very good.
Ooh, how beautiful this face.
Yes, but these are not so beautiful and important as your work.
The importance of mathematics is that it can be applied to many other things.
Short pulse can be used to form electromagnetic shock waves. A hobby for Demetrios was photographing nebulae, a strenuous, meticulous process taking some 2 hours exposure for just one picture.
It gives me joy to do it. I am connected with this universe. This is a famous nebula, the Lagoon. My wish is that when I die, at that moment I will be doing mathematics.
Christodoulou is now a maths and physics professor in Zurich's ETH after stints at the Quran Institute and Princeton University, where he went for his PhD in physics before the age of 17. His thesis?
Opened up a field which is called the thermodynamics of black holes.
But his true calling was evident in high school in Athens.
He was a genius in maths. The teachers were saying that.
He was brilliant. This is what helped him to make this very glorious career.
It began when he was 14.
There was some problem in Euclidean geometry which drew my interest, and from then on I was completely hooked to study mathematics and theoretical physics.
In the next 2 years, Demetrios completed his high school and university studies.
My parents wanted me to have a normal, happy childhood.
And he did, growing up in this Athens neighborhood.
Extremely happy, even though we were quite poor, because people, they loved each other.
As a mathematician, Demetrios emulates Archimedes.
He combined the perfection of logic with a great imagination.
As a man, Demetrius concurs with Pythagoras, who said, in life, there are people who sought gain or glory, but the best sought truth.
I would like to be remembered as one who sought the truth, did not find it.
But after having gone their separate ways, married, had children, Demetrius found childhood friend Nicoletta 30 years later.
I said I have to be with him.
Indeed, I felt some extremely warm feeling. I said, this is somewhere where I really belong.
They've been together since 1996.
She's with me all the time.
All the time. Never leave him alone. Never.